Okay, so today we're going to dig into something that's pretty fundamental when it comes to getting these large language models to really perform well. And it all comes down to this idea of reward modeling.
Right.
Now, reward modeling is basically how we tell the LLM what a good response actually looks like.
Yeah, it's like the guiding principle.
Right, like we're not talking about a simple right or wrong answer here like you'd have in a game or like a math problem.
Exactly.
This is about figuring out what good means in a much broader sense.
In all sorts of like open-ended, complex scenarios.
Absolutely. And that's where these generalist reward models come in.
And that's the real challenge. Like, how do you train a model to understand quality across so many different domains?
Right. And that's what makes this paper so fascinating.
Yeah.
It's all about a new technique called self-principled critique tuning.
SPCT.
SBCT, exactly.
Right.
And how it's used to create these DeepSeek GRM models.
And what's really interesting is that they're seeing some really promising results with these models.
Yeah, I mean, they're not just kind of keeping pace with existing methods, they're actually outperforming them.
On like a whole range of benchmarks too.
Yeah, and not only that, but they're also finding that you can actually get better performance by scaling things up at inference time.
Right, instead of just making the model itself bigger.
Exactly, like using a meta reward model to kind of squeeze more out of the existing model.
Yeah, it's a really clever approach and potentially way more efficient.
For sure. And that's all thanks to SPCT, which is a two-stage process, right?
Yep, you start with what they call rejective fine-tuning.
Where you basically show the model examples of what not to do.
Exactly, like, hey, this is a bad critique, don't do this.
Right. And then they move into a rule-based online reinforcement learning phase.
Where it learns to generate better principles and critiques.
And it's this combination that seems to be the key.
Yeah, it's about getting the model to learn both the rules and how to apply them in a nuanced way.
So it's not just about like knowing the rules, it's about being able to actively use them to judge,
Right, like it's not just memorizing a bunch of facts.
It's more like developing a sense of taste almost.
I like that analogy, yeah.
Okay, so that gives us like a good high-level overview, but let's dig into the details a bit.
Right.
So first off, why is reward modeling so important in the world of LLMs?
Well, it's all about getting these massive models to align with what we humans actually care about.
Okay.
Because at the end of the day, we want these models to be helpful, safe, and to be able to reason effectively.
Right, and we've seen how RL, based on these reward models, can really improve things like reasoning and adaptability.
Exactly.
But the paper points out a key limitation, and that's where we're currently getting most of our high-quality rewards.
Right, like in these very controlled environments.
Yeah, like games, or like solving a very specific problem.
Where the rules are clear, and it's easy to define what success looks like.
But of course, most real-world applications are much messier than that.
Way messier.
So that's why this push for generalist reward models is so important.
Because it's about unlocking the full potential of LLMs for a much wider range of problems.
Right, like imagine a reward model that could give you really insightful feedback on a creative writing piece.
Or that could evaluate complex arguments.
Yeah, something that requires a deep understanding of quality, not just a set of rules.
That's the goal, and compute plays a big role in all this too.
Absolutely.
The more compute we have, the more we can train these sophisticated reward models, and the better they'll get.
Right, so speaking of different approaches, the paper talks about these three main paradigms for reward generation.
Yep, scalar, semi-scalar, and generative.
So let's break those down a bit.
All right, so scalar approaches are the most basic. They just output a single number.
Like a score.
Exactly, and within this category, you have point-wise scoring, where you assign a score to each individual response.
Okay.
And then pairwise scoring, where you compare two responses and pick the better one.
Like the Bradley-Terry model.
Yep, that's a classic
So
example.
it's all about ranking.
Right, and then you have semi-scalar approaches, which try to add a little bit more context.
Okay.
So in addition to the score, they also generate a short textual critique.
So you get a sense of why the model gave that particular score?
Yeah, it adds some transparency.
Okay, and then we come to generative approaches, which is where things get really interesting.
Especially with this paper.
Right, so with GRMs, they actually generate a full textual critique.
And then the reward signal is extracted from that critique.
So it's not just a number anymore, it's a whole evaluation.
Exactly, and like with the scalar approaches, you have point-wise GRMs and pairwise GRMs.
And the paper highlights two key considerations for these different approaches.
Inference-Time Scalability and input flexibility.
So can you explain why point-wise GRMs stand out in these areas?
Well, Inference-Time Scalability means being able to use more compute at inference time to get better results.
Okay.
And point-wise, GRMs are good at this because they generate a textual critique, which you can sample multiple times.
So you can get multiple opinions for the model.
Right, and then you can aggregate those opinions to get a more robust reward.
Makes sense.
And input flexibility refers to how well the model can handle different types of input.
Like a single response, a pair, or multiple responses?
Right, and again, point-wise, GRMs are great at this because they can evaluate each response individually.
So it's a very flexible approach.
Very much so.
Okay, so let's move on to this idea of using principles to guide reward generation.
Yeah, so the paper talks about the challenge of generating high-quality rewards in these broad general domains.
Where we don't have those clear right or wrong answers.
Exactly, and they explore this idea of using principles to help the model make judgments.
Kind of like in constitutional AI.
Right, where you define these high-level ethical guidelines.
So these principles act as a kind of moral compass for the reward model.
Yeah, exactly, helping it to navigate those tricky situations.
And they did some interesting experiments with this.
Right, they compared self-generated principles with filtered principles.
And what did they find?
Well, surprisingly, just letting the model generate its own principles didn't really work.
Interesting. You'd think these powerful LLMs would have a good grasp of what makes a good principle.
You would think so, but it turns out that the principles they came up with didn't actually improve reward quality that much.
Huh.
However, when they used filtered principles that were specifically chosen to align with the ground truth, they saw a big improvement.
So it's not just about having principles, it's about having the right principles.
Exactly. Principles that actually reflect what we consider to be good.
And that leads us to their main contribution.
SPCT.
Self-principled critique tuning.
A two-phase training approach that's designed to get these point-wise GRMs to generate adaptive, high-quality principles and critiques.
So it's all about learning to generate the right principles on the fly.
Exactly.
And this SBCT process, it starts with rejective fine-tuning,
RT.
where they essentially show the model examples of bad critiques.
Right, it's like saying, hey, this is not what we're looking for. Learn from this mistake. And then the second phase is rule-based online RL,
where the model is actively reinforced to improve its ability to generate both the principles and the critiques.
using a GRPO setting with a KL penalty.
So they're using reinforcement learning to really hone those principle and critique
Yes.
generation skills.
Exactly. And this whole SPCT methodology, it's not just about getting better overall accuracy.
It's about specifically promoting that inference-time scalability we talked about.
Right. By training the model in this way, it becomes much better at leveraging multiple samplings at inference time.
To produce those more nuanced and reliable reward signals.
Exactly.
Okay, so you mentioned earlier this idea of unpinning principles from understanding to generation.
Yeah, this is a key concept.
So how does SBCT actually achieve this shift?
Well, the traditional view is that principles are just these static rules that the model knows beforehand.
Like a set of commandments.
Right, but SPCT flips this on its head and treats the generation principles as an active part of the reward generation process itself.
So the model is actually coming up with the principles as it's evaluating the response.
Exactly, and this is done by formulating the task of generating principles and generating critiques as a joint learning objective.
So the same model is doing both things.
Right, and this allows the principles to be generated dynamically based on the specific query and responses.
Which makes them much more relevant and effective.
Exactly. It's all about tailoring the principles to the context.
Okay, and then we come to inference-time scaling, which relies heavily on sampling.
Right. The main technique they introduce is voting with generated rewards.
So how does this voting process work?
Well, for a given input, the DeepSeek GRM generates multiple sets of rewards, each based on a different set of principles that it has generated.
Okay.
And then it sums up those individual reward scores across the multiple samplings to get a final aggregated reward for each response.
So it's like getting multiple opinions from the model and then taking a vote.
Yeah, a very democratic approach to reward modeling.
I like it. In this voting process, it effectively expands the reward space, allowing the model to consider a wider range of perspectives.
And they also randomly shuffle the responses before each sampling to avoid any positional biases.
Okay, and they take things a step further with meta-RM guided voting.
Right, so they train a separate, smaller reward model called a meta-RM.
And what does this meta-RM do?
Well, it takes those multiple sampled reward vectors as input and outputs a meta-reward score for each one.
So it's like a judge of judges.
Exactly. It's learning to identify which sets of rewards are more reliable.
Based on the data from that initial rejective fine-tuning phase.
Right, so it's using the model's own past mistakes to guide its current judgments.
Not really clever.
So this meta-RM guided voting allows for a more refined and intelligent aggregation of those reward signals.
Okay, so let's get to the results. How did DeepSeek GRM perform on these various benchmark datasets?
Well, they tested it on a range of established reward modeling benchmarks.
Like reward bench, PPE, RMB, and real mistake.
And they used standard metrics like accuracy and ROC-AUC. And they also re-implemented a bunch of baseline methods to ensure a fair comparison.
All based on the same GEMMA 227B base model.
Right, so everything's apples to apples.
And the results.
Well, even without any inference-time scaling, DeepSeek GRM 27B outperformed all the baselines.
Impressive.
And then when they added in the inference-time scaling, particularly the meta-RM guided voting, the performance jumped even further.
So this approach is really paying off.
It is, and what's really remarkable is that DeepSeek GRM 27B with meta-RM scaling actually performed better than a much larger model with 671 billion parameters.
Wow, that's a huge difference in size.
It is, and it really highlights the efficiency of their approach.
Instead of just throwing more parameters at the problem, they're finding a smarter way to utilize compute.
And their ablation study also provided some valuable insights.
What were the key takeaways from that?
Well, they found that the rule-based online RL phase of SBCT is essential.
Okay.
And surprisingly, non-hinted sampling during RFT seemed to be more effective than hinted sampling. And they also confirmed the importance of training on that diverse general instruction data.
Right.
And perhaps most importantly, they showed that the ability to generate those relevant principles is crucial for performance.
So that's not just a side benefit, it's a core feature.
Exactly. And how did it stack up against other publicly available reward models?
Yeah. How did it compare to those behemoths out there?
Well, they found that DeepSeek GRM 27B with meta-RM scaling actually performs competitively with models like Nemotron 4340B reward and even approaches the performance of GPT-4o in inference-time scaling scenarios.
Wow, that's impressive considering the size difference.
It is, and it speaks to the efficiency of their approach.
And you mentioned earlier the input flexibility of their point-wise GRM framework.
Right, so they showed that it can effectively rate single responses, pairs of responses, and even multiple responses simultaneously.
So it's very versatile.
And it can also incorporate a reference or ground truth when judging, which is useful for tasks where there's a known correct answer.
And what about the principles themselves? Are they only useful internally, or can they be transferred to other models?
Well, they tested this and found that the principles generated by DeepSeek GRM 27B could actually be transferred to GPT-4o.
Wow.
And in some cases, these transfer principles even outperformed manually curated filtered principles.
So they're actually learning something generalizable about what makes a good response.
That's what it seems like.
Fascinating.
And they also found some evidence that the model can generalize beyond the specific data it was trained on.
Okay.
Like adding in preference data from mathematics actually improved performance on other unrelated tasks.
So there's some cross-domain learning happening there.
Potentially.
And the paper includes some case studies to illustrate all of this.
Yeah, they show how DeepSeek GRM can distinguish between subtle differences in responses and how inference-time scaling can further enhance its judgment capabilities.
Especially in complex tasks like code generation.
Right, where the criteria for quality can be quite nuanced.
But of course, no model is perfect. So what about the limitations? What did their failure mode analysis reveal?
Well, they found that DeepSeek GRM still struggles with highly complex or domain-specific responses.
Okay.
And sometimes it can give too much weight to certain principles over others.
Makes sense.
And sometimes the generative principles themselves can be a bit off.
Happens to the best of us.
Right. And then there's the issue of inconsistencies in the ground truth annotations of the data sets themselves.
Oh, yes. The data problem.
The eternal data problem.
So while SPCT and DeepSeek GRM represent a significant step forward, there's still room for improvement.
Absolutely, but it's a very promising direction.
Okay, so to wrap things up,
Yeah.
what would you say are the most significant contributions of this work?
First and foremost, the introduction of SBCT itself.
Right, a new and effective way to train generalist reward models that promotes inference-time scalability.
Exactly. And then second, the development of the DeepSeek GRM models, which achieve state-of-the-art performance without being biased towards specific domains. And third, the effectiveness of their meta-RM guided voting approach, which significantly boosts performance through inference-time scaling.
More effectively than just increasing the model size.
Right. And finally, that shift in thinking about principles, making them an active part of the reward generation process.
Right, rather than just a static set of rules.
Exactly.
And they also highlight some interesting directions for future research.
Like incorporating external tools and knowledge sources into reward models.
Okay.
And decomposing the principle and critique generation processes into more modular stages. Yes.
Interesting.
And using DeepSeek GRM for offline evaluation of LLMs.
To get a deeper understanding of their capabilities.
And, of course, exploring how to integrate longer horizon reasoning into their framework.
Lots of exciting possibilities.
Yeah, it feels like we're just scratching the surface of what's possible with reward modeling.
Absolutely.
Yeah.
And for everyone listening, here's something to ponder. How might these principle-driven reward systems shape the future of AI alignment and evaluation?
Especially as models become even more complex and are applied in more and more domains.
How do we ensure that these powerful systems are used responsibly and ethically?
Big questions.
Big questions indeed. Thanks for joining us for this deep dive into the world of reward modeling.
It's been a pleasure.
Until next time.
See ya.